All right, our title is on the board. How do I compare two fractions? Go ahead and title that. Many of you who need to fix something on your math choice board need to fix this. So this will help you fix what you need to fix from last week's math choice board. All right, I want you to circle the word compare. I want you to circle the word compare. Now, when we compare things like in our reading, typically we're talking about how two things might be similar. So I say compare the two characters. You would then write about how those two characters are similar. In math, it's a slightly different version. We tend to use the word compare to tell me how they are different. So just slightly different.
So like opposite.
Kinda.
What are you saying? Escape?
I'm writing, you're writing. How are they different? I use the word they because you can compare many things. We can compare numbers, whole numbers. We could compare shapes. We could compare fractions. Talk about how they are different. Specifically, how their value is different. Don't tell me one of them's got a 2 in the numerator and the other one's got a 1 in the numerator. Don't tell me nothing. Talking about the value. What is that number or fraction worth? Now, there is one very important step when we are comparing fractions. We talked about this a couple weeks ago with Miss Williams. What do we have to make sure happens before we can tell which is more or less? When we compare fractions, there's something we have to make sure before we can start comparing them. There's something we have to do. Please don't make extra noises, that's not helping. Colby, do you remember?
The fractions have to be equivalent.
Nope, they don't have to be equivalent. You're on the right track. That's just not the right words. They do not have to be equivalent or equal, no. Because that defeats the purpose of us comparing. Evelyn? Close. Why?
Because so that you can, but you need to draw equal spaces and put them on top of each other, so you know if like it's half of something or.
Okay then.
Have the same hole.
They have to have the same whole. We cannot compare small pizza versus large pizza. That's not fair. They have to have the same size whole. When I compare fractions, they have to have the same size whole. Give you some seconds to write that. So, how do I show that? Evelyn already told us. If I'm comparing two fractions using a bar model, I'm going to stack them because that makes it a lot easier for me to compare. Do I have the same size whole? Do we see that the hole is the exact same size? This hole right here is the same size as this hole right here. Yes? Write it down. If I'm writing, you're writing. I already passed third grade. It's you that's got to do it. How would I use it on a number line? Like, how would I do that on a number line? Not a trick question. How would I compare two fractions on a number line? Rylan?
So you would make two number lines the exact same length?
Yeah.
And then put how many parts you want?
I'm going to make two number lines that are exactly the same length. I could do that. I wrote something down. That means you need to write something down.
This.
If I wrote it, it needs to be in your notebook, Sam.
This. Scroll.
Now, sometimes, especially with number lines, they will compare two fractions on the same number line. Think of it as a layer. I know Ariana and I have had this conversation. So they've taken these two number lines, and instead of keeping them separate, I don't know if I can move it, there it goes, kind of. They will layer them on top of each other. That's a really bad drawing because my number line's not straight. But just know that you could layer them. Yep, you could stick them on top of each other. So then you would have two different fractions on the same number line. We kind of looked at that yesterday in yesterday's number talks where we had halves and fourths on the same number line. Okay, so far so good? Okay. So let's look at this problem. You do not need to write the problem, but we are going to figure out what it is that we are counting. So Caitlin thinks that she is walking a farther distance than her friend Alexis. What does farther distance mean? Caitlin thinks she's walking a farther distance than her friend Alexis. What does that mean? Heidi?
It means like, let's say I walked 1 mile and Evan walked 2 miles. Those would be different distances.
Okay. What does it mean to walk a farther distance? Dig it? Yeah, like a longer distance or more. So Caitlin thinks she walks more than Alexis. That's what that's saying. So far, so good?
Yeah.
Caitlin walks 4/6 of a mile to school, and Alexis walks 4/8 of a mile to school. Do you agree with Caitlin?
No.
What was Caitlin's opinion again? Because we got to know what Caitlin thinks before we can agree. Mackenzie, what's Caitlin's opinion?
She thinks she walked the longer distance.
She thinks she walked the most. Okay. Let's figure it out.
That's how she thinks she does.
Let's figure it out.
That's how she thinks.
I got 2 people, yes? Yes. So I need to, you want to do bars or number lines? All right, let's draw 2 bars. Can I make one of them really long and one of them really short?
No. Same length.
They have to be the same hole, yes. Please make your bars the same size hole. Stacking is the easiest way to do it. You don't have to have them stacked, But I like to stack them because then I know that they're equal size.
Sorry. I should draw a rectangle and stack them.
Yes, because now I know for sure that they are equal size.
I'm gonna draw one like that and then
We did.
don't like.
I like to stack them. I don't care if you stack them, but this way make sure that they are the same size. All right, I'm going to put a K for Caitlin and an A for Alexis. Does not matter what order as long as you've got a K bar and an A bar. All right, let's start with Alexis. No, sorry. Let's start with Caitlin. How many pieces do I need in Caitlin's bar? I'll wait until I see every single person's hand. How many pieces do I need set up in Caitlin's bar? The answer's not on my face. You should probably be looking at the board. No, you're not. You're looking at me.
Oh, look at. You can look.
How many pieces
Still saying look at.
do we need in Caitlin's bar? Ariana,
Still saying.
do I need 4 pieces?
No.
Oh. Ariana, what is Caitlin counting by? No? What is Caitlin counting by? No? Macklin, you want to help her out?
The denominator is 6, so I think she wants to. She needs 6.
Yeah, she's counting by 6, Ariana, because that's our denominator. She walked how many sticks? Ariana? What? She walked 4 sticks, but we have to make all 6 pieces. Does that make sense? Yes? All right, go ahead and draw. Partition, break apart your 6 pieces for Caitlin's bar. John?
Look at tile pieces.
No. Mackenzie, how many of those pieces did she walk? 4. Can I color them wherever I want? Yes, I can. Don't do that. Mathematically, yes, you can color them wherever you want. Don't do that. Color the first 4. Since she's walking a distance, that tends to make a little more sense anyway, right? She walked all of them in a row. So far, so good?
Mm-hmm.
Question? No? What?
She kind of. I just figured out another way she kind of walks more because 4, 6 is closer to like the hole in 4.
Interesting. So Colby's noticing if Caitlin walks 4, 6, that's pretty close to 1 whole mile. What fraction would be 1 whole mile? What fraction would be 1 whole mile? Bryson?
6, 6.
It would be 6, 6. She's only 2 6 away from walking a whole mile. But let's look at Alexis. She walked 4 8. If Alexis walked a whole mile, what would that fraction be? if Alexis walked a whole mile, what would that fraction be? Kinsey?
8.
Is she close?
She's halfway.
Kinda. But is she as close as 2 jumps?
No.
Nice. In the math world, we call that working smarter, not harder. Colby said, hey, I'm going to look at these fractions and I'm going to say, oh, these are kind of closer to a whole. Now, we're going to prove it, so we're going to do the work harder too. But that thought, working smarter. What size pieces does Alexis need? What size pieces does Alexis need? Jalen?
1/8 size.
She needs 8 pieces. All right. Make them into 8s. Madison, how many 1/8 pieces did Alexis walk?
4/8.
She walked 4 of them. Could I put them wherever I want?
Yeah.
Yes. Is it going to make it easier for my brain?
No.
Put them at the beginning. Now we've got a nice, easy picture to read. Can I easily tell who walked more?
You too.
Who walked more? Not a trick question. Who walked more? Huxley? Caitlin?
This really, you can't compare because there's no meters different.
Wait,
No, the whole is not different.
I'm confused.
The whole is a mile. A mile is the same no matter how you chunk it up.
I'm confused right now. I'm
You're
confused.
still, I've heard you all 4 times you've said that. Please stop announcing that. Their whole is a mile. They just chunked it differently. You can do that. Right? Think about 5K. Some people ran, some people walked, some people walked. Did they all run a 5K? We just chunked it up a little different. Say it again. You run some, you walk some.
Actually,
Exactly how you did do at recess.
Question.
Question says, do you agree with Caitlin? Answer that in a sentence. I agree or disagree with Caitlin because, and then you finish the sentence. Give me a secret thumb when you're done. Yes. I don't. What'd you write?
I wrote if you, I agree with Caitlin because if you look at my clean and work, Caitlin's model is more filled than
Caitlin's model is more filled than Alexis. There's his evidence. Mackenzie wrote something similar. You can talk about how your model shows Caitlin's got more than Alexis. Colby and Caden wrote something slightly different. Caden, what'd you write?
I agree with Caitlin because 4/6 is closer to a whole than 4/8.
So Colby and Caden are using that logic that, hey, we're pretty close to 1 whole. Well, who's closer? Caitlin is closer to 1 whole than Alexis. There's your evidence. Heidi, what'd you write?
Match lot with Jalen.
Love it.
I agree with Jalen because 4/6 is greater than 4/8. I know that because on the model is more filled than
On the model, use that model as evidence. Evelyn, what'd you write? Two 6 doesn't cover more of the area.
No.
4/6 covers more of the area. That'll work. Next blank page. We already wrote that down. Title, which fraction is bigger? You write the title, and then your subtitle is those two fractions. We're going to be doing this for a couple of fractions, so you only have to write the title once. Which fraction is bigger? You're writing the title, which fraction is bigger? Alright, let's use some logic. Work smarter. Not harder. We're going to do the hard work too. But let's go ahead and say, what would you expect to be bigger? Which one would you expect to be bigger? We're going to prove it. But go ahead and start thinking about it. Which one would you expect to be bigger? Madison?
2-4.
Why?
Because it has bigger numbers.
Give me better reasons. Madison, you're on the right track. Madison says, I think 2/4 is going to be bigger. I expect that, but why? Why do you think 2/4 would be bigger than 1/4? Mackenzie, why? Oh, I need better reasons than that.
Yeah.
Why would 2/4 be bigger than 1/4? Macklin, what you thinking?
Because there's one more hole than
Not one more hole, one more piece. Okay, Rylan, what do you think?
Both of their denominators
Uh-huh.
are 4.
Yep.
Which means that they both have the exact same part.
Yep.
But 1/4 is only one shaving, while 2/4 has 2 shavings.
Oh, Rylan said, hey, we're counting by the same thing. Right, Madison? What are we counting by? Fourths. But one of them has 1, and one of them has 2. Which one would you expect to be more? The one with 1/4, or the one with 2 1/4 pieces? Do bars or number lines? Pick your poison. Compare, prove it. When you're done, give me a secret thumb. You can do bars or number lines. Pick your poison. Compare, prove it. Secret thumb when you're done. You've got 2 bars, right, John?
Yeah.
Did you put 1/4 or 2/4 on top?
I put 2/4.
So you split it into 4 pieces,
And I put 1/4.
and then you colored in 2 of them?
Yeah.
1/4 was on bottom, so you split that into 4 pieces, and you only colored in 1?
I'm telling you that which one's farther.
Which one takes up more space? That one's bigger. So far, so good?
More colored in.
Squiggle line underneath. Squiggle line underneath. You do not need to write the title. It's going to be the same title, but you do need 2 new fractions. Ooh. 3/6 or 3/8. Write those 2 fractions because we're going to be comparing them. Before we compare them, though, work smarter. Which one do you expect to be bigger? Think about the size of the piece. Which one do you expect to be bigger? Mackenzie, put your pencil down. This is the thinking part. Tegan? Why? Okay, so Tegan's saying, hey, I know, Mackenzie, that 1/6 pieces are going to be bigger than 1/8 pieces. And I have the same number of them, right? There's 3 1/6 pieces, 3 1/8 pieces. Tegan's thinking 3 6 will be bigger. Let's find out. Bars or number lines, I don't care. Prove it in your notebook. Secret them when you're done. Raise your hand if you figured it out. You've got some evidence. You figured it out.
Wait, I'm confused now.
Bryson, which one is bigger?
3/8.
3/8 is not bigger, no.
Wait.
3/8 does not take up more space.
I see what you learned and somewhere inside the school.
This piece and that piece are very different sizes. Neatness counts a lot with fractions. If you do not make your pieces equal size, you're going to have a very hard time doing this. Redraw the whole thing. Don't erase. Redraw the whole thing. Don't erase. Redraw the whole thing. No, yeah, underneath. If you are not neat, you're going to have a very hard time comparing fractions. Huxley, which one's bigger? 3 6. We're going to kick it way back to 2nd grade with a math symbol that you probably forgot about. No, are we adding anything?
The multiply.
We're not multiplying anything.
Compare.
We are comparing. Are we subtracting anything? No.
That's not a symbol.
All of these are symbols, Vinny.
Even that's a
3
symbol.
6 is greater than.
Wait, I see it. I know. Wait, I think I'm not.
That symbol. Means greater than. Unlike the equal sign, which means that it's balanced, that symbol means, hey, that front side, way bigger. Yes. Yeah, kind of looks like it's unbalanced. Last one. Draw a squiggle. No, thank you. I know that you're raising your hand. You're going to be patient because I don't call people just because they raise their hand. 5 6 versus 1/3. What do you expect to be bigger? Think about it. Which one are you expecting to be bigger? We should not be drawing anything. You can look at this and make a pretty good guess. You better stop. Heidi, which one are you expecting to be bigger?
5 6.
Why?
It's closer to the hole.
Okay, Heidi says 5 6. I'm expecting to be bigger because it's almost a hole. Huxley, which one do you think will be bigger? Why? What do you mean by that? Yeah, are 6 size pieces big or little? Yeah, so Huxley says, hey, I know 5 6. I only have to do a little jump, and then I've got a hole. How else do you know that 5 6 might be bigger than 1/3? Mackenzie, what do you think? We're not sitting there not thinking. Carl, what do you think?
I think 5 6 is bigger than 1/3.
Why?
Because 5 6 is bigger than 1/3 because it's
gonna ask a trick question. You ready? Put your hand down. Listen to my trick question. Which fraction has the bigger size pieces?
I see.
Which fraction is gonna have the bigger sized pieces? John, you think you know?
1/3.
1/3. Those are way bigger pieces
Yeah.
than 1/6.
Yeah, but tell you why.
But is 1/3 gonna be the bigger fraction?
I can
Prove
tell.
it. Bars and number lines. Pencil ready.
I can tell you why.
What symbol do I need? I'm writing an equation. Actually, an expression. What symbol goes in there? Several of you wrote it. I saw Tegan write it. I saw Mackenzie write it. Not an equal sign, I'll tell you that.
No.
Not good? Which is what? Because we have two of them. We have a greater than, we have a less than. Yeah, because 5/6 is greater than 1/3. You should have that written down. So far, so good? No, I didn't. This says 5/6 is greater than 1/3. I could be very tricky and write 1/3 is less than 5/6. But that's just being fancy. Probably not kindergarten. Definitely first grade. You did. You might have said the words. I doubt you used the symbols. You don't have to convince me. I don't care. We're not in kindergarten anymore. You don't have to convince me.